We're still on section 0.6, factoring. We're going to work problem 16. Now, on problem 16, you see two terms. You see that it's one term minus another. It's called the difference of two terms, or a binomial difference. If you look carefully at the first term, 16x squared, that's a perfect square. The second term, 25y squared, is a perfect square. You remember from our last section on shortcuts for multiplying that the way that you get a difference of two perfect squares is when you multiply a binomial sum times its corresponding binomial difference, or the first term of each of your binomials that you multiply together to get this result is going to be the square root of the first term here. 4x times 4x gives you your 16x squared. One of the binomials is going to be a sum, a plus sign. The other is going to be a difference. And what goes right here is the square root of this term, if it's a perfect square, which it is, 5y and 5y. So whenever you see a difference of two perfect squares, one of the easiest things to factor. It factors to its corresponding binomial sum and difference with the square root of each term. And that's number 16. Next, we will work number 28. In the textbook, problems 19 through 44, the book will expect you to be able to mix and match the different techniques that you've learned to use for factoring polynomial expressions. On this particular expression, the thing you want to notice first of all is that you do have a common factor to all three terms. You can factor an x out of each term. So if you have a common factor to all the terms, you always want to do that first. So I'm going to do that. X times x cubed divided by x is x squared. 16x squared divided by x would be 16x. 64x divided by x would be 64. Now, you're not through. You want to look at what you arrive at here and ask yourself, can I still factor anything that I have? And this trinomial can be factored using the FOIL method backwards. So I'm going to write x as a product of the two binomials times the x. Use the FOIL method backwards. The first term, what did you multiply to get your x squared? Is going to be x times x. And then the rest of this is easy. Two numbers you can multiply together to get 64. And when you add them together, so you get your inner and outer terms, you get 16. There's going to be 8 and 8. So that's the complete factorization of the expression that we started with. It is okay, and I don't know how the textbook will write the answer, but it's perfectly okay to write x plus 8 times x plus 8 as x times x plus 8 squared. I'm satisfied with either answer, whichever one you see in the back of the book. You ought to recognize it either way it's written. And that was problem 28. Let's try number 40. When I look at problem 40, I see two terms, I see a difference, and I suspect that each of these is a perfect square. And so it's going to factor to a pair of binomials, where it's going to be a binomial sum times its corresponding binomial difference. What do I multiply together to get x to the 8? Well, that's x to the 4th times x to the 4th is going to be your first term. One of them is going to be plus, the other minus. And then the square root of 81 would be 9 and 9. Again, you look at what you have, and you're not finished yet. The first term, you can't do the first factor, x to the 4th plus 9. You can't do anything else with that. I'm going to bring it down and write it just like it is. But x to the 4th minus 9, perfect square minus a perfect square, that can be factored again to a pair of binomials. It'll be the square root of the first term. What do you multiply to get x to the 4th? X squared times x squared. And the square root of 9, one's going to be plus, the other minus, 3 and 3. And there's your final answer. So don't quit halfway. Don't stop. Don't do the first step. and stop, because you haven't, the purpose is to factor this expression completely, and you're not finished until you factor it completely. There's your answer. Now, that's the examples for the problems on section 0.6. The problems are, the assignment is on the website. You should, if you'll look at my examples and the way that I worked them here, if you'll look at the examples that are worked out in the text, and if you'll work with your study buddy, your tutor, go to the math lab Monday, Tuesday, Thursday night, 7 to 9, you should be able to do any of the problems on that assignment. Some of them you may have to try several times. You may have to scratch your head a bit, but you should be able to get them. So do the problems that are on the assignment for section 0.6, and when you've finished all that, then there'll be another set of videos for the lecture and the examples for problem set 0.7 on algebraic fractions.